So when we're talking about multiplying rational expressions, last class we were simplifying rational expressions. When we multiply, it's almost the exact same process, except now we've got two, and we're going to combine those two rational expressions through multiplication. So again, the first step would be factor the numerators and denominators completely, identify any x values for which the expression is undefined, and then our last is cancel out common factors. So it's really just the same as when we were simplifying, except again, we've got two rationals rather than one. So our first example, we've got 15x squared times y cubed over 15x cubed y to the fifth times 2x to the fourth y cubed. And this technically isn't a rational expression because we have y's as well, but that's okay. It works the exact same way. So in this case, we've got single terms in each piece, so there's no factoring to be done, which means we can go ahead and identify any x values or any variables values that give us 0 in the denominator. In this case, x cannot equal, if we plug in 0 for x, 0 times anything else is still 0. So x cannot equal 0, and because we have y's as well, y can also not equal 0. So then the next thing would be cancel out our common factors. So we've got 15 on the top, and we're dividing it by 3. So the nice thing about our multiplication is you can cancel out either across the top, anything on the top with anything on the bottom. Because again, that multiplication we can kind of think as just one bar. So if it's on the top, you multiply across the top and multiply across the bottom. So you can kind of think of it as this one bar. So we got 15 divided by 3. Both of those are divisible by 3. So that leaves us with 5 on the top and the 3 on the bottom is gone. Then we have a 4 and a 2. So 2 and 4 are both divisible by 2. My 2 disappears, my 4 is replaced by a 2. And then we can do the same thing with our x's. So I've got x squared divided by x cubed. My x squared can disappear, and I'm left with just an x in that spot. And then I can do the same thing with my y's. I've got y to the third divided by y to the fifth. Or I'm going to combine them to make it a little bit easier for us. Y to the third times y to the third gives us y to the sixth. We've got an x to the fourth left over. And then we've got an x times an x, which is going to give us an x squared. And y to the fifth times y squared is y to the seventh. Of course, we still have our numbers as well. So then we can reduce that a little bit further. So our final answer, we have those 5 halves. X to the fourth is bigger than my x squared. So we're going to keep our x in the numerator. And again, subtract the smaller exponent from it. So 4 minus 2 leaves us with 2. And then our y to the 7th is bigger than y to the 6th. So again, 6 or 7 minus 6 would leave us with a 1. We don't have to split the 1. So there is our reduced. Okay. Now, for actual rationals, which is what we're going to be working with, we have x plus 3 divided by x, or 6x minus 6 times x minus 1 over x squared minus 9. So the first thing we want to do is we want to factor the numerators and denominators. Well, in this case, both my numerators are already factored. But my denominators can both be factored. So our first one, we got 6x minus 6. That would be greatest common factor. They both have a 6 in common, so we can take that out. And that leaves us with 6x divided by 6 is x. And negative 6 divided by 6, negative 1. And then our last one, x squared minus 9. It's one of those perfect squares. So we can split it into 2. Take the square root of the first, we get x. Take the square root of the second, we get 3. So then what we have So everything is factored. Now we want to identify our values in our denominators that give us 0. So in this case, I have a 6 by itself. There's no x with it. I can ignore that 6. And then we have x minus 1. So the value of x that gets me 0 in this denominator would be a positive 1. Then we have 2 over here. So x that gets me 0 is both a negative 3 and a positive 3. And that's all my excluded values. And then the last step, again, cancel out the terms that we have on the top or in our numerator that we have in our denominator. So I've got an x plus 3 in my numerator and in my denominator. I can mark them out. I've got an x minus 1. I can mark them out. Everything in the top is gone. That leaves me with a 1 in the numerator. Right? And that leaves me with a 6 times x minus 3 in the denominator. So that is how our multiplying rational expressions works. Do you want to do 1, 2, or 3 on the bottom? Number 1. We got 12x to the 5th. 6 squared. Yes. So again, whenever we need to simplify or reduce this, but before we do that, what are my excluded values? What gets me 0 in the denominator for my x's? 0. What about for y? 0 as well. So then that lets us then start canceling things out or simplifying. I've got 12 divided by 6. What would that reduce down to? 2. And I've got 9 divided by 3. That just reduces down to 3. And then I'm going to kind of do what I did on that one. I'm going to combine all my x's on the top or in our numerator. So we've got x to the 5th and x cubed. That's going to get us x to the 8th. I've got a y squared and a y. Again, add your exponents. So 2 plus 1 gets us y cubed. In my denominator, x squared and x squared. This is x to the 4th, and y to the 4th and y to the 3rd. This is y to the 7th. In our final answer, I've got a 2 times a 3 left over for the numbers, so that's going to give me a 6 in the numerator. And then for our exponents or our variables, we've got x to the 8th divided by x to the 4th. X to the 8th, again, is bigger, so we're going to keep our x in the numerator and subtract the smaller exponent from it. So 8 minus 4 is 4. Y to the 7th is bigger, so we're going to keep our y in our denominator, subtract the smaller exponent from it. That leaves us with 4. We want to do 2 or 3. 2. Yeah, number 2. So x minus 2 divided by x plus 4 over x squared minus. So again, first step is we want to factor. So we can factor our first numerator. What can we take out? What do those two things have in common? 2. Leaves us with 2 times x minus 1. Again, divide both by 2. And our second numerator, what can I do with this one?
Factor out x.
Factor out an x. That leaves me with x times x plus 4. My first denominator cannot be simplified or factored. And then our third denominator, again, that's our trinomial factoring. So let's start off with x. We look at our c value to determine our signs. It's positive. So if it's positive, you use the same sign as your b for both. It's negative, so both need to be negative. And then 2 is prime, so we can only do 2 and 1. So 2 times 1, or negative 2 times negative 1 gives us positive 2. Negative 2 minus 1 gives us negative 3. So now that we factored it, we need to find our excluded values. So what values of x get us 0 in the denominator? For our first one, what value of x gets us 0? Negative 4. Our second one? 2 and 1. Okay. And then we start canceling out. So what do we have on the top? What do we have on the bottom? We've got x plus 4s. We also have x minus 1s. And so that leaves us with, we have 2 times x over x minus 2. Now again, nothing can cancel out between these two. That negative sign, or that subtraction of 2, means this is a whole term by itself, and you either cancel out the whole term or none of the term. So we can't get rid of the x's, we can't cancel out the 2's. Any questions on multiplying? So then let's add one more step, and let's look at dividing rational expressions. So dividing rational expressions works almost the exact same way. We've got 2 little things that we've got to remember. First is, what happens when we divide by a fraction? Because rationals are fractions. If you divide a fraction by a fraction, what happens to the second fraction? What do we really do? We multiply. So in this case, when we divide by a rational expression, again, we're going to flip it and turn it into a multiplication problem. So again, first step, again, we would factor and flip, as I call it. But in this case, we can't factor it. We're just going to go ahead and flip it. So everything stays the same on the left side. But everything that we were dividing by, we flip our numerator and our denominator. Then we would factor it. We cannot factor it. So we can go ahead and put our excluded values. So in this case, x again cannot equal 0 because we're multiplying, same with our y. And then we can start canceling things out. I've got 4 divided by a 2. Leaves us with 2 on the top. 6 divided by 3. Leaves us with another 2 on the top. I'm going to go ahead and combine across the top. So I got x squared and x is going to give me an x cubed. Y to the 4th, y squared. Again, add your exponents, gets us y to the 6th. Divided by x cubed, x squared, x to the 5th, and y to the 5th. Y squared gets us y to the 7th. So our simplified version, we've got 2 times 2 gets us a 4 in the numerator. And then let's simplify our variables. X to the 5th is bigger, so our x stays in the denominator. 5 minus 3 gets us a 2. And then y to the 7th is also bigger, so our y stays in the denominator. 7 minus 6 leaves us with a 1. So there's our simplified version, or multiplied division version. When it comes to our rational expressions, again, same kind of concept. Okay. So again, the first thing we want to do is we want to flip and factor. I do those in the same step. So our first one stays the same. We don't change it at all. But we can factor it when we rewrite it. So we got 3x plus 6. We can factor out that 3. That leaves us with x plus 2. Now we need to flip our second or our divisor. So we've got x squared minus 1. Turn it to a multiplication problem. So we can factor that x squared minus 1 into x plus 1, x minus 1. And then my x minus 1 just moves to my denominator. Now here's the second thing that I was talking about. The part that we need to pay attention to is originally my x squared minus 1 was in the denominator. Well, now it's in the numerator. So if it was ever in the denominator, we still need to check it for excluded values. So our excluded values are now both denominators and my new numerator. So what gets me 0 on our first one? Negative 2. And then we've got positive 1. And in the top, we also have negative 1. So that's really the only thing different whenever we're doing our division. Right? We now have 3 things to check for our excluded values, not just both denominators, but are also our second numerator. And then we cancel things out. So we got x plus 2's, those cancel out. We've got x minus 1, that cancels out, and that leaves us with x plus 1 over 3. Any questions on dividing rationally?